Hi guys, today let's focus on rectangles. In this chapter we've been focusing on parallelograms and their rules, and now we're going to be getting into more specific quadrilaterals. Rectangles, the biggest thing you need to know is that it's a parallelogram with four right angles, so that's its formal definition. And also, what's important about rectangles is that you know that they have the same rules as a parallelogram, so the opposite sides are parallel and congruent. The opposite angles are congruent, and then the diagonals bisect each other. Now, you don't necessarily have to write those down as long as you have those written down from the parallelogram section, but it is important to know that those rules still apply for rectangles. But we really only have two new rules today. The first one is that in a rectangle, all the angles are going to be right angles, and that's going to be helpful if you're missing any measures. And then the second new rule is that the diagonals are congruent. So in parallelograms, all we knew was that the diagonals split each other in half. Well, now we know not only do they split each other in half, but the lengths of them are actually going to be the same as well. So if I have my rectangle drawn in here, all my angles would be 90. So I'm going to put right angle boxes in all of them. And then I'd say that the diagonal GT is going to be the congruent to diagonal AH. And that would allow me to find these missing segment lengths if I needed it. All right, so two new rules. Make sure you write those down, draw in the picture, and then we can jump into some examples. The first example that I have says solve for x if RTUS is a rectangle. It's important to know that this is a rectangle first, because knowing it's a rectangle is going to give us a hint as to how to set up our equation. Remember that we're dealing with a rectangle, which means that all the angles add up to 90. And if we look here, we've got 8x plus 4, that's angle UTS. All right, and then we've got angle SUR down here, that's 3x minus 2. Well, notice these are not the same size, but we know that one whole angle, maybe angle T, will equal 90 degrees. And right now, all we have is part of angle T. We just have this little part here. But because it's a rectangle, we know we can move this up here to put a 3x minus 2 in this little corner, because all these angles are congruent now. And so then I can set up an equation, and I can say that 3x minus 2 plus the 8x plus 4 is going to add up to equal 90 degrees, because these two angles together make up all of angle RTU, or angle T. And now it's just a matter of solving. If I add 3x plus 8x, I get 11x. Subtract negative 2 plus 4, and I get positive 2 equals 90. Subtracting 2 to the other side, we get 11x equals 88. And then divide by 11, we get x equals 8. And then that was all they wanted for this problem, so we'd be done. Now, if they did ask you to find the measures of the angle, maybe they said find the measure of angle SUR, then all I'd have to do is take the value I found for x and plug it in here. So I'd have 3 times 8 minus 2, which gets us 24 minus 2, which is 22 degrees. And that'd be my final answer there. So just make sure you read whatever the problem's asking for. Make sure you answer all part of the question. Now, the last example we're going to go through is if you are given points or a graph and you have to determine if it's a rectangle or not. The easiest way to tell would be to go ahead and plot your points, so we'll do that really quickly here. So there's J, K is here, L is at negative 4, negative 4, so that's that one, and then M is at 4, negative 3. Now sometimes it's going to be really obvious whether or not it's a parallelogram, or sorry, a rectangle or not. Sometimes it may not be quite as easy. So you could use multiple methods to determine this. The first method you could use is to measure all the side lengths and see if the opposite sides are congruent. And then you could also look at their slopes. Remember, a rectangle has 4 right angles. So you could look for all of these. Now, we can't just assume that they're right angles. We have to calculate. And the easiest way to calculate if they're a right angle is to compare the slopes of each side. So remember that slope, if I want right angles, then my sides have to be perpendicular. All right? And so if I look at the slope of, let's say, KJ and the slope of KL, I want these to be opposite reciprocals. Write that down. Opposite reciprocals. That should be familiar from previous chapters. So let's find the slope of kj. Well, remember we can just use a graph and go rise over run. So I'm going to go up 1 and then over 1, 2, 3, 4, 5, 6, 7, 8. So over 8, that's 1/8. I'll put that here. The slope is 1/8. And then I'm going to do the same thing for k to l. So I'm going to go up 1, 2, 3, 4, 5, 6. So over 6. And then to the left 1. And that's why I put a negative there, because I'm going to the left. So if I look at these slopes, 1/8 and -6 over 1, are they opposites? Well, yes, one's positives and one is negative, but are they reciprocals? No, because if I flip 1/8, I get 8 over 1, not 6 over 1. So these are not perpendicular, so it cannot be a rectangle. And then we'd be done. So slopes are the easiest way to tell, especially when we know rectangles have to have right angles. You're not going to be using a protractor for these. I want you to use the slopes of the sides to calculate it, and then you can go from there. Also, remember, rectangles have congruent diagonals. So if you wanted, you could use the distance formula, or you could use Pythagorean theorem and figure out the lengths of the two diagonals and see if they are the same. And if they are, then it would have to be a rectangle. If they're different, then it would not be. All right, so there's multiple ways. I'd write down the multiple ways you can. And if you have any questions about any of those different various approaches, please let me know. That's it for rectangles. Thanks for listening.